So let's do examples 1 through 6 here. You can write them one at a time, but I'm going to write down number 1 at least. It says in exercises 1 through 6, evaluate the expression. So I'm going to write down number 1. So evaluate, so the word evaluate, it means figure out the value of. Evaluate, figure out value. Figure out the value. But first, learn how to spell before you do that. Figure out the value. Now the word expression, you see, it's one of those words in math that everyone's seen like a gazillion times, but no one can define. If I were to offer $10,000 to you to define expression, no one in here would win the money. I'd keep the money. What the heck is an expression? It's one of those words that always come up in math, but like in English, to express yourself means to communicate an idea. I'm bored, I'm excited, I'm expressing myself. But in math, an expression is a collection of 3 things. It's a collection of does anybody collect anything in here?
Nope.
One of them was from a party, and I
Got you. I got you. All right, so an expression is a collection, not of bottles, not of Yu-Gi-Oh cards, baseball cards, coffee mugs. It's a collection of 3 things. It's a collection of numbers. I trust you guys know what numbers are. If you don't know what a number is, I'm going to kick you out of my class. Just kidding.
Number.
You know what a number is? You know what a number is. You're going to scare me if you don't. So it's a collection of numbers. Watch this now. Variables. Variables. Variables are what? What's an example of a variable, Dominguez, in all your math knowledge? What's a variable? In math. Variable.
They use a letter
Right?
instead of a number.
Right, it's a letter that represents a number.
So a substitution for a number.
Exactly. So X, Y, Z, A, B, C, right, Dominguez? Those are all variables in math. So again, I'm trying to define what an expression is. It's a collection of numbers, variables, and operations. Now when I say operations, I'm not talking about cutting you open and taking your spleen out or something, or doing heart surgery. That's an operation. In mathematics, an operation is, I'll put in parentheses, adding, subtracting, multiplying, dividing. So right here on the directions it says, in 1 through 6, evaluate the expression. Figure out the value of that expression. That's a collection of numbers, variables, and operations. It doesn't have all the 3 things. It only has numbers right now. And it has operations, because 0 power means taking it to some other power. That's an operation. So this is just a number and operation, number 1. On all these examples, there's no variables in these expressions. But just keep in mind, it's always numbers, variables, operations of some sort, some combination of some. All right, let's use our notes from yesterday. -3 to the 0 power. One of our rules spoke to a 0 power rule, huh? Anybody help me? What does that become?
1.
Nice. Remember the 0 power property? Said, look at, let's see. Is that the first one? Yeah, the 0 exponent rule. Any number except 0, if it's raised to 0 power, it's going to be 1. Any and all numbers. Let me, can you get that for me, Katarina? Let's try the number 2.
That one's 1, 2.
Exactly. Any non-zero number raised to the 0 power is 1. Right, De La Rocha? How's it going? I just wanted you to agree with me.
I was already here, but my shorts got dirty, so I had to go home and change.
I hear you. No worries. So number 1 is 1, number 2 is 1. Anything raised to 0 power is going to be 1. Now we got the negative exponent rule that we went over. I think that was the second one, if I'm not mistaken. Actually, no, yeah, the negative exponent rule from yesterday, right here. That says, look.
Put it over 1.
Right, just take the reciprocal, make it into a fraction, and then take 3 to the negative 5th, reciprocate it. I'm going to erase this for now. I need some room. So put it over 1, and then reciprocate, flip it. So it's going to be 1 over 3, but make the exponent positive now, after you reciprocate. Nice. Now we could go all the way and take 3 to the 5th power. In other words, we can do this if we wanted to. But for now, for this lesson, just leave your answer as a power, 3 to the 5th. We can go ahead and do 3 times 3 on a calculator. But right now, just for our purposes in this lesson, leave your answers as powers for now. 3 to the 5th really means 3 times 3 times 3 times 3 times 3, right? Question so far. Let's try number 4. I see another negative exponent. Let's rock and roll. I'll put it over 1. Let's reciprocate. This becomes 1 over negative 5 to the positive 3 power. That exponent turns positive once you reciprocate. Questions? On number 5, we're going to use 2 rules. Which two rules will we use? Diaz, what do you think?
I think we're gonna use the power. Wait. I think we're gonna use the power of quotient property.
Okay. The power of a quotient property, I like that because we're dividing, huh? And that one said, look,
The 7th power.
the 7th one.
Or no,
That's if the whole thing is raised to some power. In other words, that's if you have a division problem.
Yeah, sorry.
No, it's fine. I like how you're thinking because you're already thinking quotient because you see quotient. I love that thinking. But that's if everything's in parentheses raised to some power. We don't have that here.
Power then. Power of property. No, never mind. Give me a second.
That's sure. Anyone want to chime in?
Oh, quotient of powers property.
Definitely. Let's see. Quotient of powers property.
That's the 4th one.
The 4th one.
Yeah.
That is if you have the same base. I love it.
Never mind. Oh. Still wrong. Okay.
It's all right. Watch this. If you have the same base, like yesterday's, I forgot whose favorite number 27 was. But notice it's the same base, then you can subtract the exponents. Here we don't have the same base. We have here a base of 3 and a base of 9, so that's not going to work. I like how you're thinking, though. Anybody want to help Diaz?
Yeah, nobody
No
wants
phones, all right, Delotra? What 2 rules will I use? I'm going to use 2 rules in this one. I'm going to use the first and second rule in whatever order I want. The first rule says, look, anything to the 0 power becomes
Right.
1, huh? So watch this. So look at, I'm gonna rewrite this as 3 to the negative 2 power over 1. Sorry.
Next day we're gonna be yelling
3 to the negative 2 power over 1. Now watch this now. I'm going to use a negative exponent rule, which says reciprocate that puppy, turn the exponent to positive. 1 over 3 to the second. Rocking and rolling. Rocking and rolling. Go ahead.
The same thing.
It's the same thing, huh?
Yeah.
It's the same thing. The same thing.
1 over.
Nice. This becomes, look at the denominator becomes 1 again. So I got 6 to the negative 1 over 1. Reciprocate that puppy, right, De La Rocha?
Yeah.
And that becomes 1 over 6 to the positive 1 power. But just a little FYI, you never have to put 1 power, because if it's not written, it's automatically a 1 power there. It's more professional not to write the 1 power. In other words, any number that you see is automatically raised to the first power. It's just unnecessary to actually write it. It looks unprofessional, in other words. Just so you know. It's like mathematical bad manners, so to speak. Yeah, so let's do this. Let's go on with a few more. Let's put in higher gear now. Let's use some of our other rules. Where are you at here? Here we are. Get a few of these here. So let's do the same thing with 7 through 12. Then we'll go outside for a little while. And there we go. All right, going to write number 7, 8, 9. Thank you, Ms. Villalobos. Appreciate that. Thank you. So notice 7, 8, and 9. Going to write those down. Here we go. Negative exponent rule, right?
1 over x to the 6th power.
The negative exponent says just flip it, change it to the second rule, huh? So that one, okay, let's see here. So I got over 1 over x to the what, Diaz?
Positive 6.
Positive. So once you reciprocate again, change the exponent. Not the base, change the exponent.
Equals 1.
Thank you. Number 8's a freebie. Anything to the 0 power is 1. That's the first rule. 9 is a combination of stuff. We've got to be careful here now. Here we go. So this is going to be, let me rewrite this, but I'm going to rewrite the y to the 0 power is 1 now. This is really 7 times x to the negative 4 times 1. Is it not? So far, so good. Now, 7x to the negative 4 times 1 is just going to be 7x to the negative 4th. Right? Because anything times 1 is itself. So I'm just rewriting everything like that now. Because anything times 1 is itself. All right? What is 7 being raised to? What power does 7 have right here?
To the negative 4th power?
Is it being raised to negative 4 power, or is it, which, are you sure?
No, I'm not.
What's being raised to negative 4 power?
The x.
The x is, not the 7.
So it's 7 times x to the negative 4th power?
Exactly. So this, let me rewrite this. This is really 7 times x to the negative 4th power. Let me separate it out. The 7 is not being raised to any negative power, only the x is. So let me change this to a fraction. Look at that. Let me reciprocate that. In other words, let me use the negative exponent rule. So this is really 7 times 1 over x to the positive fourth, right? I'm using the negative exponent rule. How should I turn 7 into a fraction?
Put a 1 under.
Just put a 1 underneath it. The way you always turn anything into a fraction, put a 1 underneath it. So now I got a fraction times a fraction. Back to junior high days. Numerator times numerator, 7 times 1. Denominator times denominator, 1 times x to the fourth is x to the fourth. We're done. Nice. Cool. All right.
Let's equal to 1. Wait, no. Never mind. I thought the 9 was a 0. Sorry, blind people thing.
That's fine.
that
So
equals
the
1.
only thing that's being raised to 0 power here is the f, and the g is being raised to negative 9 power. The 12 is being raised to what power? What's the 12 being raised to?
1.
The 1, huh? If it's not there, it's automatically 1. So the 12 is being raised to the first power. So let's rewrite this now. Here we go. This is 12 to the first power. I'm just going to rewrite it. Times f to the 0 power is going to be 1 times g to the negative 9th power. I'm just separating them out. I'm separating every factor. Every item that's being multiplied, I'm separating it out. So 12 times 1, no, that's elementary school. 12 times 1 is 12. So I got 12 times g to the negative 9th. And now I'm going to do exactly what I did with example 9. Let me take the g to the 9th power and use the negative exponent rule. This is really 12 times 1 over g to the positive 9th power, yeah? Nice. So our final expression then. Notice I use the word expression. Remember the collection of stuff? It's a collection of numbers, variables, and operations. Our final expression is, excuse me, numerator times numerator is 12. Denominator times denominator is g to the 9th. Nice. All right, we're going to stop there for now. Do a little bit more tomorrow. So you have your notes in front of you.